Hey folks, welcome back. This is Joel, and in this video, we will continue with our discussion on SD-WAN. We will actually get into another interesting piece of SD-WAN, which is the data policy. Right till now, we have talked mainly on the control policy aspect, but in this video, we will actually jump into the data policies. Right, so which is going to be super fun. Okay, so just to recap, I mean, for folks who are basically coming directly to this video, just to recap what we have done is this, where we have set up all our sites, which are basically we have the headquarters over here, right? We have the headquarters. Give me a minute. Okay, so we have the headquarters on this side, and we have like the branch one over here. This is the branch. Sorry, this is 101, right? We have 102, and we have 103 over here. So all of this is being set up, which is totally cool. We have also done and we have also gone and kind of like set up TLOC extension as well, right? Between these two guys over here, which is on the headquarters side as well as on the on the branch 101 side, right? So we have the TLOC extension. You can see the yellow transport, which is the MPLS transport, expanding to the BR1-1, and likewise the internet is also getting extended here. Similarly, we have done the same thing there. So what I mean to say is we have complete end-to-end transport setup, which is the internet and MPLS, right? And we have the controllers up here, which is on the internet side, right? So you can see that in the topology as well over here. So we have simulated an internet kind of environment and put up all my controllers up there. So that is pretty good. The only change which I've done is I've added another small cloud here, which is the actual internet, right? So till now in the previous videos, we were actually using we were basically using all these nodes which are there in my topology. But in this particular video, since we are looking into data policy, I wanted to kind of connect to the actual outside internet as well, right? When I say actual outside internet, maybe something like say Netflix or Google, right? I want to connect to something outside. So that is why I had to basically connect or bridge my actual internet over here to my internet router. So I've done that, right? Which is cool. Now next, now that we have done that, and you probably can check out my previous videos as well to get into an idea about what we have done when it comes to control policies and TLOC extensions and all of that. I'm not gonna again go through all of that right now. Nevertheless, what we will do today is very interesting. Like I said, centralized um, data policy, right? This is what we are going to look into today. Now, here, when you're talking about centralized data policy, if you take a particular edge, right, any of these edge or V edge, right? So you have two, let's say two sides to it, right? One of the side is the transport side, another one is the service side, right? You agree with me, right? The transport side is the VPN 0. This is the VPN, in our case, it is VPN 10, right? This is VPN 0, right? And this is VPN 10. But it can be any other VPN as well on the service side. It's not hard and fast, right? Now, when you're talking about this data policy, it has to be applied, right? Either when the traffic is going from transport to the service side, or when the traffic is coming from service to the transport side, right? So that is the use case, and obviously you can't apply this way, right? You can't apply it within your service. This is not allowed, or you can't apply it like this, right? This is not allowed. You have to apply it from the service to transport or from the transport to service, right? So that is the idea behind the centralized data policy, right? Now, just like any of my other videos, what we will do is we will get right to it by probably starting with some use cases, right? Because I really hate spending time just doing theory. Rather, we do labs and we understand our concepts better. So, my first use case is going to be, let me just get rid of this if it is causing any confusion. Awesome. So the first use case is going to be what? Let's say we want to limit the communication between the remote sites, right? What I mean by that is, so BR3, right? Which is these are my remote sites, right? We have site 101, 102, and 103, right? So these are my remote sites. What if I don't want direct communication, between my remote sites? I want to limit it, right? So let me use a different color, maybe like a red, right? So I basically don't want this, right? I don't want this to happen, right? I don't want direct communication, between the remote sites. Rather, what do I want? Let me use a different color, probably this one. So what I want is, if they have to talk to each other, then that traffic first should go to the headquarters, and then from there it has to go like this, right? Something very similar to hub and spoke, right? But hub and spoke, we did it using what? We did it kind of like using your control policies, centralized control policies. So in this video, we are basically looking into how some of that can be done using data policy, right? So that is our use case. We don't want direct communication between this. We want all the traffic to go through hub. And probably let's also add the fact that, we will allow all the rest of the traffic, which is going to the internet, right? We would want to also allow that. So there would be another traffic, from here, which would want to probably go to the internet, right? Going to the headquarters and then, go to the internet this way, right? So we would want to allow that as well, right? So this use case is blocking one kind of traffic and allowing the rest of the two, right? And let's see how we can do that using centralized data policy. That being said, let's check, as of now, without having any policies in place, how is this playing out, right? How do we do that? Probably let's go to my diagram, right? Let's go to this branch one. We have two PCs here, right? On branch one and branch three. So let's look at the branch one. I should have it somewhere here. Right, so on my branch one, let's see if we have direct communication right now to the other branches. Like for example, branch 2, 172.17.2.10 is my branch 2. Yeah, see, I have connectivity to branch 2. Let's check if we have connectivity to branch 3, 3.10. Yep, there you go. I have connectivity to branch 3. So it's direct connectivity, right? I have right now, as of now, I have direct connectivity. Why? Because it is more like it's a full mesh, right? We don't have any policies in place, right? So yeah, so let's start with this. We can also check this out even in my so let me also show you my vmanage. This is my vmanage, right? And as of now, I can also show you using our amazing tools which we have, or maybe let's save that for later. Let me show you, because I just want to set the context when it comes to what we are doing. So let's go to probably VR3, right? Something which we have used in the past. And let's see, from VR3, let's use the troubleshooting. And I want to show you the simulate flow. Or maybe let's do trace route. I think that's going to be better. So on the trace route, if I do something like, destination network, which is 172.17.2.10, right? And VPN 10, obviously. And from here also VPN 10. And when I do the start, you should basically see that it should go directly, right? So you can see it is directly going to the BR2, which is the, site 102, right? It is directly going. It is not going through the hub as of now without any policies in place. Awesome. So let's open a new tab. So now we are starting with the actual policies, right, where we'll do what we set out to do. So let's see how we do this. So under the policies tab, I would probably, once it loads, right, so under the policies tab, I would probably see under the centralized policy, I have a bunch of policies, right? So let me pick one of it. Probably let me use this control policy which I had used before, right? I'm just going to be piggybacking along this, right? So yeah, before that, let's create some lists which we might need, right? We have done this quite a few times now in all my previous policy based videos, so you'll get to know why we are doing the lists and all of that. Let's go to the data prefix, right? So you can see there is a prefix here and data prefix, right? So data prefix is something which you use when you are using the data policies, right? So in the data prefix, now what do? We have to define our headquarters subnet, right? What is the headquarters subnet? let's call it as um, headquarters or data prefix. Let's say data prefix PFX, right? Underscore headquarters underscore network, right? So we are basically calling the headquarters network. And what is the network? Which is 172.16.0.0/16, right? That's my subnet on the headquarters side. I'm happy with that. Let's go ahead and add it. Next, we also need to create one more for my, uh, because you see what we're trying to do. I was saying, let me use this. We want to limit this, right? So we need to figure out when will this come. Only when you're talking to the private addresses, right? From BR3, when you're talking to the private addresses, because of public addresses, we still want to, public, when I'm saying public, it's basically going out to the internet, right? We want to allow that. So only for the private addresses, that is, the RFC, I think 1918, for that, we need to limit it. So we'll basically define all the private addresses which anyone would use in their network, and we'll define the policy for that, right? So let's do that. So what are going to be, what is, this is data prefix PFX, yeah. And let's call this RFC 1918, right? That's basically, the RFC is nothing but all the private addresses, right? /8, okay. I believe the next is 172. Doesn't it take commas up there? It should take commas if I'm not wrong. It should take commas. Yeah, let's check that. So 172.16.0.0/12, I believe, right? And the other one is 192. Yeah, 192 and 168. And sorry, there is 192.168.0.0 and /16. I think that's good. So these are my private address space, right? Let me add, and there you go. So we have this whole thing done. Next is we will go to my let's say what, we'll go to traffic policy, and under the traffic policy, let's go to the traffic data, right? So this is where we define your centralized data policy, right? So traffic data, and here we will look into the add policy part, and we'll say create new policy. So we'll basically call this policy as data policy from the service side, right? Why? Because like I was explaining earlier, we can have the data policy either from the transport to the service or from the service to the transport, right? It's basically the direction on where you are going to be applying, right? In my case, I'm basically applying it from service, when the traffic basically comes from the service and going towards the transport, right? So as I'm basically naming it as data policy from service. Now, once done with that, you need to add a sequence type. Since we are kind of like limiting some kind of access, right? We are basically limiting the remote sites from talking to each other. I like to call this kind of like an application firewall kind of a policy, right? If you really don't know what you're doing, then you can go with the custom, because that will have all the other options, right? But if you really know what kind of a use case you're playing around, then you can use explicitly, right? Whichever of this makes sense. Now, we might not cover all of this, but I would strongly advise you to look at the documentation for each of these, right? So we will start with the application policy, application firewall. Now, once done with that, let me also kind of go and change the name of this, right? Probably because I might add more of these in the future, so I don't want to get confused. So I will rename this to, this is kind of like the firewall to the headquarters, right? Because we are basically putting some policy so that we basically make all the traffic go to the headquarters before going to the headset, right? So just something intuitive, right? Awesome. So now the sequence rule. So when you're adding a sequence rule, let's do this. So what do we need to do? So for the first thing is, let's add a match condition, right? So for match conditions, we'll do destination data prefix. So here you have, right? So destination data prefix. and what is going to be the destination data prefix, which is the headquarters, right? Uh, yeah, and what we intend to do is some kind of an excuse me. Yeah. So what we intend to do is that we also kind of, so in the background, this there'll be some kind of an ACL which is going to be applied, right? Because it is data, right? We are talking about data policy. Don't confuse data policy with control policies. In control policies, underlying how this works is probably in terms of route maps and route policies, right? But in case of data prefix, when you're talking about data prefix, sorry, when you're talking about data policies, what we are trying to do is, if there is a traffic matching, right, a particular, say, ACL, then we are, kind of, let's say, navigating that traffic somewhere else, or we are changing the next stop to somewhere else. So that's basically the difference between data policies and control policies, right? So that is the reason. So we are basically doing this, right? You'll get to know more as we proceed. Okay. So what we also need to do is, since in the underlying we are basically ending up creating ACLs, and we are not explicitly creating ACLs, right? So the tool or the SDWAN we manage does it, in the backend when it is generating the configuration. But we also want to kind of look at the ACL counter. So let's create a counter for that, right? So under the actions, we will accept this, and then we will enable a counter, and we'll call this counter as ACL to headquarters. So this will kind of help me, match all the traffic, right, and kind of help me give, it will give me some kind of a metric, right, later to check it out, right? So hope this is pretty straightforward, right? The first rule is basically we are allowing all the traffic, destination traffic, right? All the traffic which is headed towards the headquarters, right? We are allowing it, we are enabling it, and we are also trying to keep a counter to match it. Now the second thing is we haven't done the reject part. So what is the reject part? We want to reject all the, for that also let's go and select this, right? For the reject part, excuse me, okay, did I create a, so I don't want to create a sequence rule. Instead I want to create a sequence, okay, did I lose that? Damn it, okay, I lost it. Okay, anyway, let's create it once again. So this was, I wanted to create a separate sequence type for that. So this is data from service. You need to be a little careful with all the GUI, otherwise you basically end up losing the configurations which you do, right? So now that being said, let's go and add a sequence type. And this is going to be my, like I said, the firewall to the headquarters. Basically, this will take care of all my traffic which is going to the headquarters, and we are basically allowing it, right? So under that, let's go add this destination prefix. We are basically selecting whatever we have created earlier, and under the actions, we will enable it, accept it, and under the counter, let's create a counter called as ACL to headquarters. Right, now let's save this. Now let's go and add one more sequence type. So when adding one more sequence type, it's basically going to be the firewall. Let's rename this to firewall to the internet, right? Because do we want to do the other one first? I think this is fine, right? Firewall to the internet, and I think yeah, that should be fine. So let's call this firewall to the internet. Right, and let's add the sequence rule here, where we will prevent this particular prefix. I mean, you can do this again different types. I'm just showing you one way of doing it. Probably you might have a more simpler way to do it. So actions, under the actions, I'm going to drop it. See the selection over here. I'm going to drop it because I don't want any kind of direct communication between the remote sites, right? So let's drop this. Once we have dropped it, let's save it over here, right? So we have, what we have done till now is we have firewall towards headquarters, firewall towards INET. It's not actually internet, INET in the sense, my internal network, right? So I have dropped the traffic which is going towards my internal network, and what about the internet, right? We talked about three use cases here, or three conditions: the red one, the blue one, right, and the green one, right? So we have prevented this. We have allowed the traffic to go via the headquarters, but we still haven't taken care of this traffic which is going outside to the internet. So how do we do that? For that, you just go down to the default action, because rest of the traffic is basically captured under the default action. So we go down to default action and we have say we will enable this. So right now it is getting dropped, everything. Let's accept it, right? There you go. So I think we have done all the stuff which we need. So let's save this. Okay. So there we go. So once done, what we will do is uh, I think that's looking pretty good. Let me just see if there is anything else which we have missed. Yeah, looks good, right? So let's go and now enable this. So we are right now here, which means I would still want to go back over here to my centralized policy. Let's see what we have on the centralized policy. So this is where I told, right, we are going to piggyback. So let's edit this. I mean, you can create even a new centralized policy if you want. I'm just piggybacking on the old ones which we have used in my previous video. Now here under the topology, this looks good, but okay, let's see. I have a feel. Okay, so I have a feeling we already have a couple of policies from my older exercises or the older videos. I really don't want to apply these, so I would want to kind of like remove them, right? So let's go and click and detach these. So there you go. I'm gonna detach that, and I'm gonna detach this as well. These were all my control policies which I had used earlier, right? That looks good. Now what I'll do is I'll probably go down to traffic rules, right? So let me go down to the traffic rules, and under that you will find the traffic data, right? And here let's import the policy which we earlier created, right? Which is here, import, right? So now that it's imported, what do we do next? Let's go to the policy application, because we have to apply this policy, right? We have to tell the vSmart, because it is again centralized policy. We need to tell the vSmart on what sites and what VPN list it has to apply, right? So let's go again down to my traffic data here, and here we need to new site list and VPN list. So let's add that. So we are going to do it from service, right? Not from tunnel. We are going to do this from service. So the select site list will be what? We will basically be applying this to the site spokes, right? We have created this list earlier in my previous videos. I'm basically going to be applying that, because at the end of the day we want to apply this for all the spokes, right? We don't want to do anything on the headquarters, right? We want these policies to be applied on the spokes. That's why I've selected spokes. And the VPN on which we want it to be applied is VPN 10, which we already have as well created earlier, right? If it is not there, you can go and create it under the list, right? Now once done with that, you can basically go down and add it here, so it would be visible like this. So that being said, now it's all about saving this policy here. Once you save it, you go down here and you activate it. So when you do that, this policy gets pushed where? On my vSmart, obviously. But there's something interesting which I want to show you here. I think if you remember from my earlier videos or in my overview video, I was talking about the centralized data policy, and I also talked about how the centralized policy is created, or you can see it on the vSmart, but the vSmart is then going to push it down to the vEdges. That might be a little contradictory when we talk about centralized, because I've always used the word centralized where the policies are going to reside only on the vSmart. But in case of centralized data policy, the policy does get pushed onto the vEdge, but it will not go to the running configuration, right? It will be saved in some kind of a let's say a new memory or something. Let me show you that. So it's already pushed, which is good. Let me now go down to my so let's I don't think I have my I have my vSmart here, right? So there you go. So that's visible. Let me just clear the screen. There you go. So what we will check now is something like, I think, show running config. Um, I have maybe policy here. Right, there you go. So you can see the DP effects, right? These are basically the stuff which we added, right? You can see here. I was just using the word access list, but actually it got converted to prefix list, right? So whatever we had written there, under the policy has got translated into configurations here. You can see, whenever it is matching the traffic which is towards the headquarters, it is accepting, and whenever it is matching the traffic towards, the internal remote sites or between the remote sites, it is dropping, and then you will have a default action which is accept, right? Which is basically the internet traffic. You can see all the lists which we had, created also visible here. Awesome. So let me just close this. So I think let's just get it here. Okay, cool. So let me just open up my sites because we might have to do some kind of a show commands. I think I have not connected them. BR1, BR2. What else? We also need this guy. Okay. So let me go down to BR1-1. Let's start from here, right? The first branch. Now here also let me show you where, if you do show run policy, I believe you will not find that, right? See, you don't have any policy because, like I said, because it is centralized policy, you don't find it directly under the running configuration, right? But if you see something like, I believe it is show policy from vSmart, yeah, there you go. See, if you do show run policy, show policy from vSmart, you can see that policy visible here, right? So you can just for now, think of it like it is stored in some kind of a special memory, right? Where from where it is going to be used, but it is not going to go down to the running config. Awesome. So that being said, now what we will do is that let's go back to the testing, right? We had the whole testing setup here. I believe we did the testing from, you see here, we did earlier, we tried to connect from, this is my branch 1. From branch 1, I was trying to ping my branch 2 and branch 3. It was working. Now let's see if it works. See, the ping is not working, right? Just for the satisfaction, let's wait it out. Let's wait for the ping to time out, right? So you can see now the policy has activated. We are not able to talk directly. We are not able to talk between the remote sites, right? Excuse me. So we have actually completely, removed the communication between the remote sites, right? But let's say, are we able to talk with the headquarters? Let's see. The headquarters is at 32 dot. It's 172.16.32.1. So this is one IP on the headquarters side. There you go. See, we're able to talk to the headquarters, which is working fine, right? Let's see if we can talk outside to the internet, right? Let's ping the DNS, which is Google's DNS. There you go. See, we are able to talk outside as well. Okay, so just one small correction. I might have, now that I think of it, I might have talked about, BR3 acting like a hub and spoke. Actually, it is not like a hub and spoke. The idea which was there in my mind was to allow the communication from BR3, the blue one, right, which you see here, the blue part. The idea was to allow the branch to talk to the headquarters, right, in each of this direction and not like a hub and spoke, right? We probably might do a hub and spoke later, but for now, I think we have achieved what we wanted to do. We have prevented the communication between the remote sites. We have allowed the communication to the headquarters, and we've also allowed the communication outside to the internet, right? So that being said, we can also probably check out that counter which we set up, right? Remember, we set up a counter for the, I think we set it out for the headquarters, if I'm not wrong. So let's check that. Do we have that? We should have that counter on my BR1-1. So show, I think it's show policy, if I'm not wrong. Show policy, something like data policy filter. And I think that should give you, there you go. See, we did a ping. So there were 4 packets, so much of data which was sent. And you can see that counter has updated ACL to the headquarters, right? Pretty cool, right? So we were able to do some kind of traffic filtering. We were able to do something which probably we would have done earlier using control policies, but now using data policies. We were able to restrict two sites from talking to each other, and we were able to allow few sites, or we were able to allow the communication to the headquarters. Awesome. Next, use case number 2, right? Let's move on. So the use case number 2 is going to be, sorry, right? So the use case number 1 was basically limiting, let's say, limit access, right? Limit access between the remote sites actually. But what I want to do is, in use case number 2, I want to tweak. So I want to allow a little of access. So I want to allow access here. And what I mean by that is, you see the red color over here. So I want to give some kind of, access between the remote sites. As of now, there is completely, blocked. There is no access between the remote sites. But I want to kind of, be a little lenient, and I want to probably allow the access, say, on a specific port, right? So I want to probably do that. Let's say I have this CIFS, right? It's basically a file sharing service, common internet file share, if I'm not wrong, right? So this works on port number 445, TCP 445. So I want to allow this between the remote sites over here, right? I want to allow only that particular port to communicate on the remote access. So that's basically my use case 2, right? So as usual, let's go and do the pre-testing. So probably let's go to BR1 and see if we are able to talk to it as of now. So if I do a telnet 172.17.3.10, so I'm communicating from BR1 to BR3, I believe, right? BR3 on the port 445. See, it is stuck at connecting. It is not able to connect, right? Because currently we have blocked everything. But now let's go and tweak our policy to allow that, right? So let's go back to my vManage. Here we go. So what we'll do now is, let's go back to my policies here. So on my policy, let's go to my traffic policy. And on the traffic policy, let's go to the policy which we had earlier created, which is over here under the traffic data, right? And here, let's go and edit it. So, so what we'll do is, let's add one more. Let's add one more sequence type, right? Which is going to be, again, pretty much the same, which is firewall to, let's rename this firewall to the site. Firewall to the site. So we are basically adding some rules now when two sites are talking to each other. And under the sequence rule, obviously, let's add a sequence rule, and it's going to be, so under the sequence rule, what we will do is we'll have to add destination data prefix, I believe. So let's go check out that. So remember, we had okay, so I don't think we have created anything for the site. So what we'll do is, I'll create something ahead of here. So you can do that. You don't have to always create a list. You can use something here as well. You can create it ad hoc. So my destination or the remote sites, they have the subnet 172.17.0.0/60. I'm going to use that. Keep using 26. We are okay. So that is done. And let's also add a protocol, right? So the protocol field for my CIFS is going to be 6. And the destination port, let's add destination port, because like I said, we are basically going to allow communication on the port 445, right? That being said, on the actions, obviously I need to allow it. So let's go top and allow this. So where is my actions? Here, and let's accept it, right? And that should be good. So we are saving. Okay, please save or cancel the open rule before saving the policy. Okay, sorry, I think I did not do that. So let's save this, right? So we have added this great, rule over here. Um, but now that I think of it, we probably will have to add it in the reverse direction as well, right? Because you see what happens is, we are basically, let's say BR3 initiates a connection to BR1-2, then we also need to allow from BR1-2 to BR3, right? Unfortunately, this is not a stateful firewall, right? So we need to take care of both the directions. So let's go and do that. Let's add another rule, right? Under the same thing, let's add another rule, which is basically for the return direction, right? So when I'm talking about return direction, the source data prefix is going to be my 172 this time, not the destination. The source is going to be 172.17.0.0/16, right? And same thing, my protocol, where is my protocol? Let's find protocol, right? 6, and the source port also is going to be 445. Right, we did it for destination earlier, now we are doing it for the source, basically for the return direction, right? That said, let's also go to the actions and accept it. So let's add this, don't forget to add this, right? So we have done that, we have done the destination, we have done the source. What else? Are we good? Okay, we are not good, because you see the ordering over here, this will not work because we have this works top down, right? So first this particular rule is checked, this is checked, and this is checked, so it goes top down approach. Now what happens is our firewall to site is basically a subset of the second rule. So if the second rule gets applied, then the third one will not even be considered and all the traffic will be blocked. So let me move this guy to the top. Can I do that? Yes, here you go. It's probably okay. I'll have to do a little bit of playing around here. Yeah, there we go. So we have moved it to the top. Now it should work. Now let's save this, activate it, next, configure, and there we go. It should start anytime now, and we should be able to test. Happening. Wait a minute. Yeah, that's done. So now let's go and test this. So when I say test, what we do is we will have to basically go back to my Windows PC. Let's go to branch 1. See here, earlier the connection was not working, but now there you go, it's working, right? So this is how it actually looks, because we are basically trying to connect to the CIFS using Telnet, right? So that's basically what I wanted to show here, right? So earlier you saw here, it was not working, but now you can. Awesome. So that was something which we did, where we kind of, but the ping will still be denied. I mean, we have allowed what? We have allowed only, I'm not sure this would work. Let's see. So we have allowed only the CIFS service, right? So if you're doing some kind of a ping, it will still not work. So if I do 172.17.3.10, right? So this will not work because we have allowed only one specific port and one particular service, right? Awesome. So that was the second use case. Moving on. The third use case is something very interesting and many people love it about SD-WAN, which is deep packet inspection, right? DPI. You would have heard about DPI in various solutions out there, and SD-WAN also doesn't disappoint you. It also has it. All right. So with DPI, what you have is that you have the capability to kind of put policies for certain applications, right? So if you don't want your end users to use Netflix or Dropbox, right, you can prevent that, right? So that's exactly what we are going to do. Now, before doing that, we need to somehow enable what we call as application visibility, right? We need to enable this on all the VHS. Now, for doing that, we have, I mean, it's not a very straightforward process. I mean, it's very easy if you're doing it from the CLI, but here it might be a little tricky. So what we are going to do is we probably will search if we have some kind of localized policy from earlier. Right, here you go, we have some kind of policy. 2 of the device templates are using this. I mean, all my I was hoping all my devices use this. Okay, so Let me think. All right, there you go. I fixed it. So what I did was there was one device which did not have this BGP policy. I just went and added it to it, right? BR1-1. It's not going to be used. The policy is not going to be used in any protocol. It's just going to stay there. I just did not want to create new policies. I'm just piggybacking my older policies, right? So what I want to show you here is that a easier way to enable your application visibility, which in turn is needed for deep in packet inspection, is by enabling it on the localized policies, right? On the localized, in fact, these were localized control policies, right? How do you do that? Now we will have to do it for both of these guys. So let's do it first for the headquarters side because we were using the OSPF on that side, right? We had created these policies before. So let's go to edit, right? Under this policy overview here, you'll find an option called application, right? You click that, that's it, save it. Right, do that. Obviously click on next, configure devices, select it, there you go, there you go. We've done it on the headquarters, I believe, R1 and R2. Let's go back and do the same thing on the uh, branches as well, right? Because we want this application visibility to be there everywhere. So let's go here, let's go edit, let's go enable application, save this, and yeah, run this next. So if you want to see, probably we can have a look. Maybe it's going to be visible here. It's going to add probably one line, into the configuration. Maybe here on the div. Yeah, there you go. See, it goes and adds this application visibility. All right, that's good. Now let's check it out. So what we'll do now is let's go to my BR1-1. Right, so we are here. We are on the BR1-1, and let's also look at the PC, right? The branch one PC. So this is my branch one PC. Let me keep it side by side. That is easier to look at. Let me open up a browser here. Well, that is opening up. Yeah, there you go. So on the browser, let me also open up a show command, which is show, I believe it's app, yeah, I think it's app something, DPI, I guess, app forwarding DPI, I guess, if I'm not wrong. Close, yeah, there you go. So this is what I wanted to show you. But now you see you have a lot of, maybe let's see if we can get the tabular version of this, right? So you can see you have, um, because of the Chrome browser, I think it's trying to use some Google updates. It's trying to connect to some accounts and all of that, right? So you can see all of those applications here. Now let's quickly go and connect to something like Netflix, right? All of us do Netflix, right? So yep, instead of that, let's go to Netflix. So this particular PC is a bit slow, so bear with me. Netflix.com, right? So once you do that, and you see here, there you go. You can see Netflix getting captured, right? So my edge device is able to understand what kind of an application it is, right? Now this is where we come in and we are going to block few applications, right? That's going to be our use case 3, right? Where we want to block probably Netflix or Dropbox or something like that, right? So how do we do that? Let's go back to my so here you see it got loaded, right? Because it was allowing the access. But now let's go back to my amazing policy page. Let's go back to policies. And when I'm on policies, let's go to lists. Let's create some lists, because we have to tell what are the applications we want to block, right? So let's create a list of that. Let's go to application here and let's create an application list. And see here that by default you have some Microsoft apps and Google apps, right? But what we want to do is let's create app deny list, and I really want to block few applications. So it's going to be, if I start writing itself, it will pick it up. So if I do something like Dropbox, I think it should be here somewhere, or maybe not. Okay, so let's see. Okay, here, let me search it here. Dropbox, yeah, there you go, Dropbox. And let's also prevent Netflix. Let's say I don't want my users to use Netflix when they are, say, working, right? So I want to block Netflix. There you go. So I've blocked it. I mean, I'm not blocked it. I've just identified it. Let me add it over here. So we have added both of these guys. And then let's go to my traffic policy, right? The same old traffic policy which we have since earlier. Let's go back to traffic data. And over here, let's edit it. Yeah, once you edit it, now over here, what do we do is we can go to the traffic which we had allowed, right? We had put in a firewall to the headquarters which we had allowed. So we could basically maybe add a sequence rule here itself, because we already have something where we have allowed. So we could add a sequence rule here directly. So let's say, or let me just think about it. Give me one sec. I mean, we could actually define a new sequence type as well. But let me just add it here. It doesn't matter, right? So this is just a way of segregating your various access policies. I just imagine tomorrow I want to kind of allow, say, FTP to my headquarters. Then I can just add FTP to that list of, I mean, let's say I want to deny FTP to my headquarters. Then it's going to be as simple as adding FTP to that application deny list, and it would work, right? So let me go down to the firewall to headquarters sequence type. And over here, let's add a sequence rule. And what is the sequence rule? So here for that, we will basically will go and select application, an application family list, and we have created that application which is app deny list. So once you select that, we obviously have to drop it. So let's go to the actions and let's drop it, right? Let's save this. Now you see, it's better to reorder this. Always keep the deny first and then the accept below. So let's go and do that. So I think we have to drag it from here. Still okay. I hate playing this game. It works sometimes, sometimes it not. Okay, there you go. So we have denied it. I mean, we have put it at the top. Now let's save this, activate it. It wasn't compulsory for me to put it in that specific sequence type. I just used that one. You could have put it in other sequence types as well, right? There you go. Now it is getting activated. Once it gets activated, we should be able to test it. There you go, it's done. Let's quickly first check it on my vSmart if the policy has come, or the update to the policy has come in, right? So if I do the same thing as earlier, which was say show run config policy, right? You will basically see the app deny list somewhere here, right? There you go. See here, you have the app deny list, and we are basically preventing Dropbox, Dropbox upload, and Netflix. These are three things which we are preventing. Okay. Now let's go and test it, which means I just need to refresh it, right? Let's have both of these screens ready here, which is BR1-1 over here, right? So let's have this, and let's also have my Netflix here, right? So Netflix had earlier worked, but now let's try to do this. So let's try to refresh this. Can I refresh it here? Let's try to refresh it, right? Right, so I just expanded the screen. You can see it is trying to load here, but it is not able to, right? You can also check it by probably opening a new tab of Netflix, and it should not be able to. Even Dropbox should not work, right? So let's do that. So netflix.com, and it should try to load, but it should fail, right? See, it's trying to, but it's not working. You see here, it's not working. So that is exactly what we wanted. We can also check it on probably Dropbox, because we have prevented Dropbox as well, right? So Dropbox.com, I believe. And if you try to do that, even that shouldn't work, right? So that was a very interesting use case. You can also see here, you can see the Dropbox application over here, right? So that is exactly what we wanted to do. We wanted to prevent Netflix and Dropbox, and we were able to do it. Okay. Awesome. So next, what do we do next? Okay, so the last use case for this particular session would be something which I want to show is let's call it as PBR for now. I mean, it's not obviously called PBR here, but I want to kind of connect it to some traditional networking policies, right? Which is my PBR, right? Policy based routing. This is because it is a use case very similar to that, right? So let me just clean up this diagram a bit because probably gonna it's a bit messy here, or I think this also would work. Yeah, and this one, let's get this rid of this. Let's get rid of this as well. Okay, so that looks good. This. Okay, so we have the diagram here, the older diagram. I just clean it up a bit so that we just don't get confused with what I'm doing next, right? Awesome. So what we're going to do next is we want to kind of do what we call as the PBR or the policy based routing, which we kind of normally do in a traditional routing, right? So in traditional routing, what happens is normally if you want to change the next hop, right? If I'm using PBR, policy based routing, I have the flexibility to change the next hop, right, based on a source address, right, based on matching some source address, right? So if the packet in the data plane, if there is a packet which is basically coming in, so say for example, let's take an example here. Yeah, so let me take this and let me explain it. So the traffic, this particular network over here, we have 172.17.3.0, I think /25, right? So if the traffic is coming from this network, right, like this, what we want to do is this is the source address. If the packet is coming like this will be the source address. So based on this source address, if the packet is obviously going to in this direction, right? Packet coming from here and it has to go to these two guys, which is 172.17.1.0. This is 172.17.2.0. Right? If the packet's sourced from here and destined to this, I want to do some action, right? But I also don't want to do anything on the routing plane or by changing the routing protocols. I want to do it on the data plane, right? So here we will be putting the centralized control policy, centralized data policy, right? Such that when the traffic coming from here and destined to this, the action which we want to do is we don't want to send it directly like this, right, using the transport. Rather, we want it to go via the headquarters and then go like this, right? So this is kind of like simulating my hub and spoke, right? We are trying to simulate the hub and spoke. And remember, we have done the hub and spoke earlier in the centralized control policy, but we now want to do it using centralized data policy, right? So that's my use case. Hope that's clear, right? That being said, let's get to it, right? So we will go down to my okay, logged me out. That's interesting. Okay, so let's go probably from here. Okay, here we are. So let's go down here and let's probably go to my traffic policy. So let's see what we have right now in the traffic policy. Let's probably go and delete all the traffic policies which we have, right? So let's go to edit here because we won't be using those anymore, right? All these ones which we had created. So we are good to go and kind of like delete them, delete and delete and delete, right? All the three. So once I do that, okay, let's obviously we have to activate this and we have to add it on the devices. I mean on the vSmart, be specific. We'll not go and remove the visibility, app visibility, which we had enabled on the VHS. Let it be there. We might use it in future. But I just want to remove the three data policies, which we had created as part of the three use cases. I just wanted to remove that. So once done with this, yeah, this is done. So let me probably go down to my branch 3, right? Branch 3 PC over here. And now let's see, we should be able to talk directly to the So I should be able to do ping to 172.17.1.10, right? Now the communication between the remote sites should work because we have removed the policies. There you go. I'm able to do that. Let's also try to do a trace route. Trace RT maybe minus T, same thing, 172.17.1.10. There you go. You can see it went to 172.17.3.1, right? Which is basically my obviously R3. So this is from R3 and trace routing to R1, right? So it went to from R3. You can see it went then to my BR1-1 directly, and then it went to the actual destination. So this is my 172.16.0.111. It's nothing but my BR1-2 actually, right? So it is this one. So it went directly like this, right, without going to the headquarters. Now that's what we want to change, right? So I wanted to show you this because I wanted to show you that before applying any policy, this is how it is working, right? Similar will be the case even if we have to do something like 2.10, that is branch 2 as well. So it is going directly to branch 2, and from there it would basically go down to my destination host. Now this is the behavior which we want to kind of change. How do we do that? Let's go back to my vManage, which is my management PC, and let's go to the policies page. And on the policies page, let's say we want to create some kind of lists. Let's do that. What are the lists? Let's create the list for my BR1 and BR2, right? Or site 1 and site 2, right? Site 101 and site 2. So let's create that. Sorry, not here, my bad. We have to go to data prefix, right? Because we want to create those prefixes. So let's go here and let's say data prefix pfx underscore br1 and br2, right? br1 basically constitutes both 1-1 and 1-2, right? Anyway, so the networks are going to be 172.17.1.0 slash, is it 24? I believe it's actually 25. Let's put 25. And the other one is 172.17.2.0 slash 25. Right? So these are my two subnets, and I want to go and add it. There you go. I've added those two subnets. Now I can go to my traffic policy here and go to my traffic data. I already have the policy. Let's go and edit it. We should not see anything in the sequence type because we have removed. But now this is the time when I'm going to use what we call as a traffic engineering, right? Because we want to control the path which the traffic takes. That's why I'm using this. We have used application firewall earlier. Now I'm using this. Awesome. So we are here. Next, what do we do? So here we will go, and the only difference is as in when you select these different sequence types, right? And when you're adding a sequence rule, these options keeps on changing, right? That's the only difference, right? So that's why if you really don't know what you're doing, then you can go and select that custom, and you will basically get all the options here, right? All the parameters which you want to use. Awesome. So yeah, that's it. Let's start by first putting the destination data prefix, which is going to be my BR1-2, which I just now created, right? So let's go and select that. So that is done. And then we will select the source data prefix because we want to apply this policy only from BR3 towards, I don't know, BR1-2. So we don't have anything for that. So let me go and create something. So it's going to be 172.17.3.0 slash 24 or 25 actually, because that's my subnet, right? That's it. On the other side, which is the action side, let's go top. So on the action side, what I want to do is obviously accept it, and then okay, obviously accept it, but then I have to change the next hop, right? What is my use case? If you look at my diagram, I don't want these guys to talk directly, but rather it has to go through the next stop, through the headquarters. So that's what I'm going to do. You can see the Dropbox loaded now because I removed the policy. Right? That's pretty cool, right? But anyway, so here what I'm going to do is I'm going to add a TLOC, or let's say, yeah, TLOC list, right? Basically, we are changing the TLOC, so that's why I'm adding the TLOC list. Now I already have the TLOC headquarters which we had created earlier, so I'm going to use this. In my previous video, we had created the TLOC list, and you can see also that we have given different weight or TLOC preference to different TLOCs. So I think the MPLS we had given 200 and the internet we had given 100. So anyway, we're going to select that. If you again want to kind of like restrict some kind of, you can do that. If you see on the bottom, you have some other options. Here you probably, if you want to change some kind of colors and all of that, you can do. But we are going to skip out of that, and we also need to add a VPN here, otherwise it won't work. So you need to add the VPN. Obviously in our case the VPN is 10. That being said, we can save this now, right? So what we did is that whenever the traffic is matching this particular destination coming from this source, we want to change the TLOC, right? That's what we did. But keep in mind, we did all of this under the data policy, data centralized policy, and we did not do this under control policy like we had done something very similar earlier, right? So now we can probably go and save this, activate, next, configure. Will take a couple of minutes. Yeah, let's quickly check if this has come up on my vSmart. Here, there you go. You can see now it has the latest policy which we created, right? The older policy, all the Netflix, Dropbox, all of that is gone, which is cool. Okay, so now we can test it out, right? So when I say test it out, we can probably go down to my branch 3, which is over here. And earlier you see it was directly talking to it, but now it should probably not do that, right? So first, actually we can just run this same thing, and there you go. See the difference? You can see 16.1.3 has come in. See the exact difference? Earlier it was happening in 3 hops, now it is 4 hops, because it is first going to the headquarters and then going. Similarly, you can probably check it for the other one as well, which is branch 101. Also, you can see it is going to 1.2 and then going down, right? So that was pretty cool, right? So we were able to kind of decide or change, tweak the path which the packet takes. We can also check this out in my vManage under our simulate flows, right? So we can check that out over there as well. So if I go to monitor, network, say I select BR3, and from BR3, if I'm talking to, say, let's go to my troubleshooting, let's go to simulate flows. Here, if I want to talk to, say, my source IP, yeah, it's 10, it's fine. My destination, I want to talk to my BR2, right? The site BR2, and I think if I hit simulate here, you will see you just have 2 paths. The reason is because we have given more preference only to the MPLS, right? We have made sure that only the MPLS on the headquarters side we have given. When I showed you when we were selecting the TLOCs, only the MPLS TLOCs had the preference of 200, the rest of them had 100. So that's why only these 2 are getting selected. If I had given the same preference, then you probably would have seen 2 more here for the internet side as well, right? Nevertheless, you can see the next stop here. It is using the tunnels which are basically for my .11 and .12, which is basically my headquarters, right? So that was a pretty interesting use case. All right, so that's pretty cool. Now while we are here, I just don't want to leave you guys hanging without showing another interesting thing. And I'm probably extending it beyond 1 hour, but you know, I want to cover everything which I have tried. So there's actually one more use case. I'd actually not planned to do this, but let me still do it because it's something interesting and which will help you understand clearly what is the difference between the control policies and data policies, right? So the fifth use case I would say is about changing the local color, right? How do you tweak the local color? That is what I want to show here, right? So what we'll do for that is, let's say BR3. Let's go to BR3 to explain this. The same here, right? The same thing, but let me now change to the headquarters, which is probably 16 and something, right? So here you go. So when I simulate this, you'll basically see four different paths which are available, right? It's because we have enabled the restrict flag, right? So it will just take when the remote control and local control are same, color are same, only those paths are selected, right? Otherwise, you probably would have had four more. Anyway, so there are four paths, which is cool. But what if I want to, using control policies, we were able to select what is the remote path, right? We have done that in the past videos. We were able to select what will be the remote path. But what if I want to select the local path, right? So say from BR3, I want only the MPLS to be used and not the internet, right? That's what we are basically going to do now, right? So for doing that, let's again, okay, go back to policies. Let's open a new tab. You'll see the difference here. So let me keep this window up here so that I can come back here to show you the difference. This is not going to take much time. We can do this quickly. But I did not want to stop the video here without showing that interesting feature, right? So let's go to the traffic policy. So under traffic policy, let's go and edit the one which we have. My mouse is playing out weird. Okay, let's just, yeah. Let's go down here, and here I would want to probably go and edit it. So on the edit screen here, we will basically go and add another sequence rule, right? For the same traffic engineering itself, we are going to add another sequence rule where let's first start by selecting the source data prefix. So the source data prefix will be what? The BR3, which is 172.17.3.0/25, right? Then we can also add the destination data prefix, which is the headquarters, because we are trying to show this with respect to the headquarters here. So let's go and select that headquarters here. And what else? On the actions side, actions. Obviously, we're going to accept it. But here you see there is an option for local TLOC color, and I'm going to select the local TLOC color to be MPLS. There you go. Select it. Yeah, there you go. I've selected the local TLOC color, and you also, like I said, you have an option here if you want to. The restrict basically tells that if the MPLS local TLOC is not available, then don't send traffic at all, right? But I'm not going to enable that, obviously. But this is where you do it, right? Now I can save this. Obviously, apply this. Activate it, obviously. Like I said, it doesn't take much time, so that's why I wanted to cover this as well. Configure the devices. And yeah, give it a minute. It's getting pushed onto the vSmart. There you go. That's done. Now let's come back here. Right? Earlier you had seen, now you see. This is from the previous session, right? So we have four various paths, because the local color can be MPLS or local color can be public internet as well. But now if I go scroll top and run the same simulate again, you'll see it has changed. Now the local color only MPLS is going to be used, right? So that's another interesting piece of your centralized data policy. It basically allows you to select the local color as well, apart from the remote color, which you can do obviously in your centralized control policy. But in centralized data policy, it gives you a flexibility to do this, right? That being said, I think we have covered almost every use case which I wanted to do. Just to recap, what we did is in limit access, we kind of prevented the remote sites from directly talking to each other, and we allowed the internet traffic to obviously go and the headquarters traffic to be allowed. The direct communication between the sites was prevented. In allow access, what we did is we kind of enabled CIFS port, right, communication between the sites, whereas the rest of all the traffic was still blocked. Ping was blocked, we saw that. We just enabled only the CIFS. DPI, what we did is a very interesting feature, deep packet inspection. So where we did was we went into the application visibility, we enabled application visibility, and on the edges we kind of prevented the Netflix and Dropbox applications from forwarding the traffic, right? So we prevented those particular applications, or we blocked those applications. In PBR use case, what we did is we kind of tried to simulate something very similar to the policy-based routing which we do in our traditional networking, where we can now change the next stop of the traffic based on the source address of the packet, right? So the packet coming from here going to these two branches, what we did was we kind of changed the next stop. Instead of going directly, we made the next stop to be the headquarters, and basically going like this, kind of simulating the hub and spoke. And the last use case, which is your local color, in what we did here is we had seen that in centralized control policy, we were able to change the remote color, which is basically used on the other side, but the local color was we were not able to change. But in case of centralized data policy, now we can change even the local color, which the VH should pick, to send the data, right? So that's all, guys. That's what I wanted to cover here. Thanks for watching, and do tune in for more videos coming your way. Thanks again. Bye.